Hello, it's Keith from Kinvert, and we're going for Orbit in Kerbal Space Program. This is in version 1.7. What? It's not telling me. Okay, but it's like version 1.7 or something. We're going for Orbit, and what I'm gonna do, I have an aerospace engineering degree. I'm gonna calculate some of this out. I'm not gonna take the time. I'm not even gonna try. But the aerodynamics in this game is approximated and everything. I don't know the coefficient of drag, and so what I'm going to do is just do a bit of a gut check. And so let's go into my little drawing thingy, and we're going to start drawing this out. Move this, reach here, knock my microphone. Okay, so first of all, we've got two things. Okay, we've got kind of Kerbin and then the atmosphere here. All right, so we've got this, hopefully you know, is 70 kilometers. And then we've got the gravitational parameter is, can I get my mouse back? All right. The gravitational parameter is 3.53, and that's E12, probably, yes, e to the 12. And then the actual radius of Kerbin, equatorial radius, is 600 kilometers. 600 kilometers. And what I'm going to do is say, what if I go straight up like this? What is this delta V? And then if I go straight sideways for circular velocity, obviously that'd be probably bigger. But anyway, what is this delta V? I'm just going to try to do it that way, because in reality you'd kind of do it this way and maybe use less energy than this, but there's drag in there. And so I'm thinking this is going to be a bit of an approximation, and then I'll aim for about 1.5 or something, and see how we get from there. So first, we want to get to 70 kilometers. All right, so for this, we can use the equation. Let's switch colors to this beautiful color. All right, we've got x of t is half of at squared plus v0t plus x0. x0 is going to be 0. And VT is what we're going to be figuring out to do this. And so we want 70,000. 70K is negative, and this is like 4.9 because acceleration for gravity is a beautifully drawn A, and it's actually negative. And so let's see, we've got this negative 4.9 T squared plus V0 of t, and we don't know what this is. What we're trying to do is figure out what velocity is going to get us up to this height, if that makes sense. So we want to figure out, it's basically, imagine if we instantly got our speed and we didn't have drag, and we just instantly had that speed and coasted up and came back down, if that makes sense. So first of all, what we really want to do is look at how would this work if we are going to free fall. You know what I mean? And so what we can do here is we're basically just going to assume that we're up here and falling down is one way to do it. So we can do this. And now what I can do is solve 70,000. I'm just doing this with a calculator because I don't feel like doing this all by hand, times t squared, and solve that for time. All right, so it's like 119 seconds. 119 seconds, and this is all very ish. And so, yeah, now what I want to do is figure out what is the velocity going to be at that time. So we have the velocity is at plus v0. So let's say that our v0 is here, and we know that we're like accelerating up. So what is the delta V that we've got to achieve to get up there? And again, this is very approximate, and I probably shouldn't be doing it this way, but so let's see. We've got our eventual velocity. Well, we've just got AT, really. And so 9.81 times 119. So we need a delta V for vertical of about 1.1 K. All right, so about 1,100 meters per second is our vertical delta V. To get from here to here, we're just going to do a suborbital dip like this, and that is this first part of the delta V. This is just very ballpark. I'm not trying to actually plan this out and go in detail. So next is the circular velocity, and that is the square root of mu over r. R is going to be 600, so we've got the square root of 3.53 E12 divided by, and E12. This isn't like E like exponent, my bad. It's like times 10 to the 12th. And dividing this by 670K, because we've got the 60,000 for what I believe is the radius of Kerbin, looking at the internet, plus the 70,000 to get up there. So the square root of 3.53 e to the 12 over 670 E3, and we've got 2,300 meters per second this way, 2.3 K. All right, and if we add these up, we can look at each stage, but we've got 1.1 K and 2.3 K for a grand total of 3.4, and I'm going to go 1.5 to be plenty safe. 3.4 times 1.5, we've got 5.1, so I'm going to aim for a delta V. If I can get to 5,000 meters, what's this going to do? Per second. I accidentally clicked a button. 5,000 meters per second, so 5K. All right, so we're going to aim for a delta V of 5K, which is probably overkill. We need somewhere between 3.4 and 5-ish. I really don't know what it is. I could look up one of those delta V maps, but I don't really want to do that. So, all right, we've got our approximate numbers. 1.1 up, 2.3 side east, and let's start doing this. Moving all my stuff back. Okie dokie. Where's the game? Boom. All right, build this thing. So yeah, for vertical, we're aiming for that. So what I'm hoping to do, and it's not going to work, but whatever, take this, and I should have a new engine, because I just spent all my science. That's my little engine. The little engine that could maybe work. And I'm going to do this, and this. What do we got? Delta V. Kerbin. What is all this? Can I just get a delta V? What have I got? Okay. oh boy. 390 meters per second. That's not even close. And that's a lot of weight. Is it counting this weight? I hope not. Alright, so let's fix the staging at least a little. Okay. That's not nearly enough delta V for this. I thought this was a high ISP at altitude. Maybe it calculates for the altitude that we're at. I'm going to try a bigger tank. Okay, whatever. Do that. Do this. Engine. Pop. 623. Is that for the current altitude? I mean, otherwise, we see the delta V equation. Yeah, so you're just kind of multiplying ISP by everything else. It might be counting this at sea level. Is there a way to tell this to be thrust 17 kilonewtons, thrust to weight 0.4 is probably good enough. Burn 113 seconds. ISP of 85 seconds. That's a problem. How do I tell it to be like in space? What if I do this? No? Let's see, Kerbin, display values, delta V, please, no. Altitude 70, well, vacuum, okay. 2500, and that is what I needed, right? Okay, so there's that part. And now for the lower stage, 1500. Okay, I think this will work. Now let's check the weight and the thrust. You know, I can just find out if there's enough thrust by just going for it. Alright, so I've got some science. I prefer to not lose this science. I don't know if it matters, but... So I'm going to bring this. This is going to put it in an upper stage, which is going to use a lot more fuel. And I might need another decoupler. Now what are we looking at? Come on. 1500, not enough. And by the way, this needs to be at ground level. But I got boosters. Okay. I didn't get radial. I don't think I ever got radial couplers. And I don't think I have enough science. Don't save, I don't know. Don't lose it, please. Let's see, what do I need for the radial couplers? Where was it? I'm always blind, like especially in the fridge. Radial coupler, 18, oh my gosh, of course. I'm 5 off for science to get the radial couplers, and that's probably what I need to make this really work. I need some boosters. What if, because didn't I get a kind of big booster? How big is this? That looks big. Looks big, right? What if I, Same, lame. Alright, how much thrust can I get out of a booster? Zoom in, come on. I'm not good at this. Pop, okay. What kind of thrust can I get out of a SRB here? One of these little guys. Flea, that's probably not enough. Mass. Oh, what's this? Oh, that's a liquid fuel engine. Well, that's not what I need, though. Hammer SRB. Variance of it. Oh, that's probably the colors. Max thrust, 197 kilonewtons. So 200 E3 times 9.81, is that what's going to get me? That's kilonewtons. No. Because I need to find the mass that it's going to force. So 200 E3 divided by 9.81 should give me the mass that I need. 20,000, so 20 tons. I'm going to try this. I have no idea if it's going to work. So I'm going to get another separator. This is getting stupid. Do that. I have a feeling I'm going to be reverting this one. Okay. That gets me there. And then what about this stage? How do I know how much? Okay, cool. Alright, so that one, yes. Boom, boom. This I can do at the same time. Why do I have multiple? Okay, give me another. Okay. Yes. Okay. Go away. Okay. That's another engine. That's gonna launch then. Okay. So, SRB, probably bad idea. Separate that engine. Separate that engine. Separate that and parachute. I don't think this is gonna work. But we're gonna try it. Okay, so I've got some science. Cluster 1, because there's gonna be many. All right. This is probably really bad. Oh, this is embarrassing. Okay. I don't even know what my new delta V is now that I added that on. I don't know how to read all this stuff. Okay. So Z, not that it matters. T, not that it matters. Okay. Too much gravity turn. Too much gravity turn. Too much gravity turn. Too much gravity turn, and I'm twisting. Oh boy. Okay. This is not easy with... Okay, now I can gimbal. This is a little... Okay. I can't even look to hit my control button. I'd like to throttle down, but I'm just too busy fighting this. I just don't think this has a chance. We'll see. And I gotta have enough fuel to deorbit. Okay, so now I'm ready to start aiming about here. I'm stabilizing a little. Okay. 20 thou, not bad. And then in here, can I see my apoapsis? Where's my apoapsis? Where can I see my apoapsis? Come on, come on. I don't want to have to always go to this. Okay, 45. Okay, I'm on fire a little. 23. I'm gonna cut this. And I'm just gonna do a maneuver here. So I'm gonna try to aim prograde. And because this engine is much better delta V up high, and I don't want to waste much of my thrust here, so I'm just going to coast up and try to cancel some of that. Alright, let's start raising this up a bit. Okay. What have we got for delta V? 2000. Oh, I think I'm pretty close. This might go orbital. It's a big hack job. Still got half my fuel. Still got 1,000 delta V. And I'm at 18. I'm going to make it. I'm going to make it. The math in my head tells me I'm going to make it. Alright, so I'm going to cut throttle here. I don't have orbital maneuvers. Okay. So I'm just going to coast up. I've got a dude in here, and so I can keep controlling it even if I lose contact. I don't know what my inclination is. So yeah, we did the math, and this should be enough delta V to get me the rest of the way into orbit. Theoretically, I've only got another 400 delta V I need to use, and I've got 1,000. So I should have plenty of extra fuel to get around, I think. So, can I time warp? Alright, I'm in space. Alright. Full throttle. And I've got to do all this manual. I don't have any sort of stability assist yet. I'm going to throttle down a bit because my apoapsis is running away from me, so I'm safe here. And I don't want to overshoot by too much. Throttling down a little more. Getting ready to cut. 76. 80. Yeah. We're in orbit. Is this going to admit it? Yes. So we're officially in orbit. That went okay. And where do I want to land? Try to land back at Kerbin. Close. Well, back at Kerbin. This is Kerbin. I want to land back at the Kerbal Space Center. So I'm going to try to time warp until that's kind of in the day side. Is that going to take forever? I mean, I've got enough delta V that I could raise my apoapsis and speed this up, because this seems pretty slow. 10 times, no, that's way too slow. All right, so at periapsis, I'm going to go out so that I can get this kind of on the day side. Try to kind of gut timer. Oh, no, wrong buttons. Okay, so I'm going to aim prograde right here. Full throttle. Okay, where's my fuel? Okay, I should have plenty. And now I can kind of time warp faster. Didn't this thing at one point tell me my period? No. I could have swore I saw a screen that told me my orbital parameters. Locked. Yeah, it won't tell me my period or anything. Okay. Hopefully I guessed about right. And so now I should be able to time warp quicker. And it should be like one more orbit, I think, and then I can start to pull her in. The button I'm hitting is the right caret or whatever, right angle bracket. I'm just trying to speed up. There we go. All right, and now I'm going to go retrograde and just pull this down a bit. Retrograde's going to be over here. Call that good. Time warp around. Is that enough light? I kind of think it is. I think I'm going to be able to see. And I've got enough fuel to just kind of deorbit gently. Okay, so now the question is, how much do I have to dip this down and where? But I'm just going to go retro. Oh, I need to do science first. Don't forget the science. Okay. Can I EVA yet? Yes. Okay, I want to cancel out any rotation here so it's easier if I accidentally let go. And, okay, time for that EVA. Don't let go. EVA report from orbit. Hopefully that's worth a lot. Review report. Save that. All right. Grab this. Observe the mystery goo. Barely any science. And collect the data. Okay. I don't know what that means. And then I'm going to go to this. I'll do that later. Temperature. Log. Nothing. Nice. Pressure. Log. Nothing. Nice. Grab this one. Open the doors. Observe. 4.9. So Jack Italy again. What else can I do? Oh, I can get in here and do a crew report. So get in here. Crew report from orbit. Boom. Review stored data. Boom. Review report. Boom. Is there anything else I can really do? I can't think of much. Alright, so let's get out of map view. I think I'm at about a good spot to go retrograde and see if I can keep this guy alive. Map view. Alright. Full throttle. Alright, so I am suborbital. And I want to aim for maybe here. I want to keep a little fuel. Oh, that's barely any. Alright, and then we're going to just watch I think I'm going to overshoot. I'm going to use it now. I think I'm going to overshoot, so there it goes. Alright, at this point I'm a passenger. Hopefully I put the staging correct so that I ditch only this and keep this. When I hit space, yeah, I'm going to keep my parachute. Bye. Is that gonna... There we go. Throw it that way. Alright. So yeah, now we're just gonna fall in. Let's close the doors. And we're going pretty quick. Review the data, do that. Hopefully we can survive this. I didn't go in super steep, did I? Not very. Alright, let's time warp until we're down into the air. We're in the air. So I'm going to be trying to do this all manual, I guess. I don't have any stability control. But we did achieve orbit. So that's one thing. We'll see if we keep the Kerbal alive. Yeah, I'm going to overshoot. Is it this? Yeah, I'm right over the KSC right now. So we're definitely going to overshoot. Hopefully not too far. It doesn't lose us too much money with the recovery. So we're at 55,000. I think we're going to hit max Q. The maximum heat at somewhere around 35,000 meters. I don't know exactly where. We'll keep an eye on the parts and try not to die too hard. That's overheating. Should I just tumble? Oh boy. Come on. Lost something. I think that was just my science. I think I only lost my science. I didn't get much anyway. What did I lose? Okay, I lost my other science. Please. The science sucked anyway. I didn't even want that science. Okay. Not bad for winging it. Alright, I can physics warp in. Can I get another crew report, or is that going to try to overwrite? Cancel that. Alright, be ready with a parachute. That's what matters here. Okay. Survived orbit. So yeah, you saw the build. To get there, fairly low tech. I'm sure that other people have gotten to orbit with less tech. But yeah, we got there. Hopefully we got some good science and money, and we can keep going down the research tree. But I'm going to call it once we land here. We'll figure out what that next mission's going to be. Yeah, that water looks way better than before. Okay, time to recover the vessel, see what we got out of this. But you saw I calculated all that out. It ended up working. It was very back of the napkin. You know, nothing was horribly precise, but I knew that there would be losses to drag and everything, and so rather than having a effective trajectory, I just assumed a terrible one where you go straight up, turn straight over, and we came up with the approximate delta V I needed, and we built a rocket to that amount of delta V. Okay, so we got 20 science. Not bad. We barely got any money back for the ship, but we got 300 grand for the mission, and boom, we've got Bob Kerman up to level 1. Probably if we do a similar mission for the other guys, we can get them ranked up as well. So yeah, the next thing we're going to do is look through the missions and see what we want to accomplish. I don't see any 3 stars, so that stinks. But we're almost probably ready to start going to Minmus. We'll have to see. I'd have to calculate that out, because I think that rocket was pushing it without the radial couplers. But yeah, this is Keith from Kinvert. We went over some of the math, very basic math with very good handwriting, impeccable handwriting, and we calculated out the parameters that we probably need to build the rocket to. We built the rocket to that, so I calculated that I needed 3.4 to 5,000 meters per second delta V, and we ended up with a total. I don't know how to read this yet, so someone please say in the comments if anybody even watches this at all. So here we've got plenty, so it's almost 4,000, like 4,000 delta V. And I needed between like 3.4 and 5, and it got us there and back. I didn't have a heat shield. I ended up blowing up my other science modules, but they didn't collect much science anyway. But this is what worked, and I will find a way hopefully to export this craft file so that you guys can also use the same rocket. But yeah, Keith from Kinvert did some math, did some space, and we will see you guys in the next video. Bye-bye.